to introduce Alan Jones. He's a computer engineering senior student. 2 years ago, he was a participant on the study abroad program, data science AI program in John Cabo University, Italy, and now he is sharing now his experience in U Chicago last summer. So, okay, Alan Jones, now is your time to
Yeah.
present.
And Alan, before you actually start your presentation on your topic, can you tell us a little bit about yourself and how you got interested in this data science?
Yeah, of course. So greetings, everyone. I am Alec Jones, a senior computer engineering student hailing from Chantilly, Virginia. And really my love for data science, I would say it started with that program that Professor Young was talking about in Rome. So it was a different opportunity for me. I actually got a scholarship to go there, and it was my first time working with different large language models and things of that sort. And I was really just interested in it.
And when were you at John Cabot? That I think was a year, more than a year ago, wasn't it? Or-
Yeah, it was 2 years ago,
3 years
2
ago.
summers ago.
Yeah, and for everybody that's on this call, for 3 years now, we've had a wonderful program with John Cabot University. That's what Dr. Bautista and Alan are talking about. This program that we have with John Cabot University in Rome, which John Cabot is an American university, and it's one and only campuses in Rome. Very, very interesting. And we have a wonderful partnership with Microsoft that has allowed us to send our students to Rome to take a course that Dr. Bautista and Dr. Carlos Terán Suarez were teaching. That course in itself that Alan participated in was called Data Science, Discovery, and Diversity. And diversity part, which was very important on this, was we were wanting to be sure that what we taught the students also got into that the students would be able to learn about how to identify biases in our algorithms. Not only identify, but how to probably mitigate those biases. And what's very interesting is because this course, being in Rome at John Cabot, attracts students from across the globe. So here were our FAMU students participating with students in such discussions about data science, how to discover, and the diversity issues with students from across the globe. And so diversity of thought is really a very important concept here. And how do we learn? What does diversity impact? How does it impact our learning? So anyway, okay, Alan, I'll turn it over and talk about your experience at University of Chicago this past summer.
Sounds good. And greetings, everyone, again. And this is my presentation on CBUT, the Q&A tool for farmers. So this is my team. Along with me is Amari Gray, Jabet Gupta, Gerardo Rojas, and Peter Anonymous. And as long as my mentors, Dr. Sadidisha Sahabomik, our TA Summer Han, and Dr. Kriti Sego. So first thing, talking about my project, you got to understand seed laws a little bit. So we worked with a growing culture on our project, and they're a nonprofit organization whose mission is to advance food sovereignty. And food sovereignty is just the rights of people to define their own food and agricultural systems. And that's something that's been diminished in the past. So we want to empower small scale farmers so they can help get their rights back. The current seed laws favor industrial agribusiness or large-scale farming rather than small-scale farmers, and they also undermine traditional seed saving practices. They're also hard to find and understand, and then small-scale farmers need clear and accessible information so they don't break the law inadvertently. So first thing I'm going to talk about is the UPOV. It stands for the International Union for the Protection of a New Variety of Plants. And there's two main acts, the 1978 Act as well as the 1991 Act. But the 1991 Act gives breeders more control, and breeders are the people who create new plant varieties. And then the 1991 Act also favors those breeders rather than small-scale farmers. So again, Agriculture, it's a nonprofit organization we worked with, and their mission is we believe in food sovereignty for everyone everywhere. And they really focus on like the little guy or indigenous cultures. And then all countries in our data set are a member of the UPOV, and they give more rights to breeders. So some of the problems that farmers are facing is that the laws favor large agribusiness, and then some of the consequences, if they don't follow the law, could be financial loss, legal penalties, and starvation. So example on the right is an Argentinian protest against the company Monsanto, and they're a large agricultural company, and they worked with the Argentinian government to come up with a law proposal that would criminalize farmers for trading seeds as well as saving them. And then some of these consequences that farmers can face for being criminalized, it could be punishments up to 4 years in jail, fines 250 times the minimum wage in the Dominican Republic, as well as seizure and destruction of crops. And this is something that small scale farmers who are really doing this to make a living or to eat, they can't face or afford. And this is just an example of the power distribution in the seed industry. There's four main companies: Bayer at 23%, Corteva at 17%, Syngenta at 7%, and the BASF at 4%. And together they take up 51% of the industry, creating a monopoly. So while the UPOV says that they're really there to help small scale farmers, they're really only helping those major seed companies. And then this is some of the barriers while just trying to understand these seed laws. They're very dense, they're lengthy, they're full of a lot of legal jargon, and they're not simplified. So really only lawyers will know exactly what the language is talking about. And there's really not an abundance of tools right now that can help navigate those laws. And this is something that we want to change. We want to simplify these seed laws for farmers and make their job as easy as possible. That's why we're creating a chatbot that answers questions based on a given country. We also want to empower small scale farmers with quick and simple information so they can focus on what they're good at, which is farming. And then we also used NLP, or natural language processing tools, to deliver accurate responses. And the reason we use natural language processing is because it makes it possible to parse through complex text very quickly and then answer questions in a plain and conversational-like manner rather than with a bunch of legal jargon. And then our chatbot, it can simplify dense PDF laws, provide quick answers, and it also supports the mission of a growing culture to advance food sovereignty. So this is a demonstration of how our Q&A chatbot works. So we have a total of 78 countries in our data set. But this is how it works. So you select the country from the drop down. You ask your question: how does the law ensure the rights of foreign breeders? And then roughly within 15 to 20 seconds, you'll get your answer depending on the question. I'll wait for it here. So yes, how does the law ensure the rights of foreign breeders in Albania? And then here's your answer. The law allows both physical and legal foreigners to apply for breeder rights under Chapter 1, Article 3, ensuring that they comply with local laws while protecting these rights internationally if necessary. And as you can see, it's a very simple and easy to read answer, and it also tells you exactly where it got it from in the text. So this is an example of what our data set looked like. As you can see on the table on the right, so there was 183 total rows or PDFs. And then there were a lot of different variables such as country, which was defined by country codes. So we had to translate those. Title of the document, the version, which was just the year, the version year, and then the language. Most of our documents were in English, with 153 documents being in English. Second up was Spanish with 15, and third was French with 9. But there were other languages as well, such as Albanian and Japanese. And this is just a map of the global coverage. As you can see, there's lots of different countries: Albania, Mexico, Argentina, Kenya, and a lot more. So this is an example of an ideal PDF that we worked with. As you can see, it's pretty well labeled, and then it's in the format that we want, which is chapter, then article. So it goes chapter 1, article 1, article 2, article 3. So it's easy to use something called regular expressions, which sorts through those titles. The only problem with a document like this would be the unnecessary white space. I don't know if you could see right under the Republic of Albania, the word decided. Instead of it being spaced out, we want that all the way together. This is an example of a more complicated PDF that we worked with. As you can see, it's half in English, half in Japanese. So it's easier, it's harder to work with. Now, although it is in Japanese and we can't directly translate that, the English translation is right under it. So we can still work with it. However, it's not exactly in the format that we would want. And then there's also documents like this that were repeated in our data set, and there might be another version that was simply English. So that's something we had to look through as well. And then this is something that we call an unnecessary PDF. It was either repeated information, it had a conflicting format, and it also had things like elements that were difficult to work with, such as tables. For example, this PDF, it doesn't have a lot of legal jargon or any laws. And then it says, it has a link to legal text, which is the document as you can see right there. But that's a link that was already in our data set to begin with. So with a document like this, we would just leave it out because it had unnecessary information. And then this is partly how our chatbot worked. So we started off with the JSON, and then we extracted entities, or in other words, the text. We put it into the LLM or the text generation model, and it'll come up with a response. We then use RAG refinement. A majority of the RAG refinement that we used was speculative because we wanted our chatbot to answer subjective questions as well as objective. So we wanted to be able to answer questions that didn't come directly from the text, kind of thinking on its own a little bit. And then at the same time, that's when the user would put in their input, it would get translated. And then that's when it would also get encoded and it would go to the response. But this is a more detailed version. So we start off with our documents or our PDFs, and then we have to do something called chunking, which is just breaking up the text into sections. And the way we did it was through regular expressions. So we found out the documents that had chapter followed by article, and they would each be separated by their chapter and their article. And then it goes into an embedding model. An embedding model takes those chunks and converts them into vectors. And those will be used in a second, but it was stored in the vector database. And at the same time, the user will ask a question. For example, what does NSI stand for? That will also get embedded. And then there's a process called cosine similarity, which will take the embeddings from the chunkings as well as the embeddings from the user input, and whichever ones are the most similar is how the LLM will come up with this response. So these are some of the different embedding models that we worked with and experimented with. And some of the things that we realized was chunking strategy affects the quality of the embedding. For example, bigger chunks led to issues in the retrieval process because the LLM is trying to go through a large chunk of text, and then it's just harder for it to sift through. So instead of giving the answer like, what is NSI? It'll say, I don't know, instead of giving the answer, even though it is right there, because it wasn't similar enough. And then different models have different token sizes. For example, the E5 base had a token size of 512. The embeddings 3 small had a token size of 8191. And then the BG M3 had a token size of 8192. And we went with the E5 base simply because 1, it was open source, and 2, it was multilingual. And we want our chatbot to be able to work with different languages in the future. So this is a comparison of some of our different LLMs that we did end up working with. So we asked them all the same question: how does the law define a breeder? And for the country, we chose Albania. And Gemma and Microsoft gave pretty good, straightforward answers. Like Gemma, according to the law, a breeder is defined as a physical or legal person or any employee who has bred, discovered, and developed a new plant variety. That's something that's very simple and easy to read for a farmer, and easy understandable. Microsoft did the same thing. A breeder refers to either a physical or legal entity, including employees involving in breeder activities such as discovering and developing a new plant variety. Those are the type of answers that we're looking for and would be successful and easy for a farmer to understand. Now, Llama, while it also answers the question, it likes to something called ramble. So this is only after the ... that answer would really take up like an entire page, just because it likes to keep on thinking and repeating itself. So although it does give a correct answer, it's not as helpful to the farmer. And then another model that we experimented with was DeepSeek. But DeepSeek is a reasoning model, so it likes to think out loud. So it says, okay, so I need to figure out how the law defines a breeder based on the context provided. And we just want to give the farmer the answer rather than letting the LLM think out loud, because it'll just ramble and ramble. Again, the answer would take up an entire page and sometimes more. And then can LLMs understand other languages? And then the answer to that question is yes, although they are limited based on the LLM. But we asked all 3 models, what does the law on protection of new varieties of plants in Bosnia and Herzegovina define? And then they answered the question, all 3, and they actually did a pretty good job. So these are the 3 main models that we worked with: was Gemma 2 billion, Microsoft 5.4, and then Llama 3. And as you can see on the right, it's a table with different response times. They were 3 of the fastest, and they were all open source, which is why we considered working with them to begin with. And open source just means it's available online. It's completely free to use. At one point, we were using OpenAI as well, but you have to pay for something called an API key, and it can get pretty pricey pretty quickly. But with Gemma 2 billion, some of the pros is it was very high quality, and it could answer those multilingual questions. But it struggled a little bit with implied meanings or those subjective questions where it had to think on its own. Microsoft 5 was good with, it was lightweight, it was fast, and it gave those concise answers we were looking for. But some of the cons with that, it wasn't as good with translations in other languages. And then Llama 3 gave accurate and detailed responses, but it was very verbose and it would repeat itself a lot. And then these are some of the ways we evaluate our model. With the LLM, it's kind of hard to measure it just because it's like text generation is kind of subjective. You don't know it. It kind of depends on the user or your target audience because people could be looking for different things. But we used Rouge 1, Rouge 2, and Rouge L scores. And that compares single words to your summary to the reference summary. And the way we got our reference summary is we took every PDF in our data set, we put it into ChatGPT and got question answer pairs for each one. It was 2 objective questions and 2 subjective. And we did that for each PDF in our data set. And then we compared that to what our LLMs came up with for each one. So Rouge 1 compares single words to this reference summary. Rouge 2 compares consecutive words to the summary. And then Rouge L finds the longest string of words that appear in both in the same order. And then these are how all 3 models perform. Gemma performed the best. Llama was second, and then Microsoft 5 was third. And then we ended up going with Microsoft 5 just because it was more lightweight. We ended up running our website off of one of my lab mates or group mates' computers, like his PC at home. So that was the only one that would run on a local server. And we ended up using Uvicorn for our web server. And then we have the domain c.farm. And then wrapping up, we wanted to empower farmers with the easy understand access to laws and regulations. We used a completely open source LLM, ensuring that the platform remains free and it's easy for a growing culture to work with. And then currently, our current prototype, it supports up to 6 users at a time. And in the future, we want to expand to all 78 countries in our data set. Right now, we're working with roughly 40 because those are the ones that work the best with the regular expressions. We only had 6 weeks to work on this project, so we didn't have time to sift through all those more complicated PDFs and find out exactly how to chunk those. We also want to enable automatic language detection. So that if you type in Spanish, it'll respond in Spanish, or you type in Japanese, it'll respond in Japanese. We also want to improve our website capacity. And this is our QR code to our website. It doesn't work right now because my group mate doesn't have his computer up and running to connect it to the server. But if he had his computer on, then it would work and it would show just like the demonstration. And these are some of our references.
Wonderful, Alan. Very, very exciting. Really appreciate that. I have some questions, but before I ask my questions, I'm going to let our participants raise any questions. So, what about participants here? Do you have questions of Alan of this wonderful presentation? Well, probably.
Well, yeah, I have a question. This is Nelly. Hi, Alan. First of all, congratulations. This was awesome, really. Did you get any feedback from the farmers or somebody who used that? What do they think about this? Has this been practiced?
No, we actually didn't get any feedback from farmers. We did talk to a growing cultures representative, and then they didn't really say too much. They just wanted a piece of code that they could add on to in the future. Mm-hmm. But that's definitely something that we've wanted to work with and plan on working with in the future. Because currently we're also writing a research paper. We're in the process of writing a research paper on this project.
So
thank you.
This, I'm sure there'll be other questions in a moment, but let me just say, this is a very, very significant production that you produced here. Let's probably share a little bit with people here. What was so you went to this experience at the University of Chicago. Nellie and I serve on the board for that program. And I'm somewhat familiar with the agenda. And I understand the first 2 weeks are supposed to be, it's a 10-week thing, I believe. And the
Yep.
first 2 weeks are supposed to bring you up to speed on data science and AI and modeling and all of this stuff. And so your background is in computer engineering.
Yeah.
Uh, what kind of background did you have in natural language processing when you started this?
Completely honest, I had none. So those first 2 weeks, they don't care what type of background you necessarily have, but it's like a crash course. It's very accelerated, but you learn everything from the beginning, from talking about like linear regression models, logistic regression, NLP. You kind of work with everything, but they get
Yeah.
you up to speed pretty quick. And then there's also a plethora of mentors there to help you the entire time. You have meetings multiple times a day. If you have any questions, you also do a lot of research, but it was a great experience.
So you just underscored a point that I try to keep making all the time, that getting into data science and getting into modeling is a tremendous opportunity for broadening participation in science, technology, engineering, and mathematics. Because what you just said is no matter what the background is, okay, you're able to get in there and do something and actually make an impact, a societal impact. So let me take you back. Natural language processing, this has been going on for more than 30 years. 30 years ago, we were looking at natural language processing. Our approach was how to recognize words, how to recognize words. How does a computer recognize words? And so here we just had to create these lexicons of phonemes. And use Bayes' theorem to see after one phoneme, what's the prediction of what other phoneme might come behind it. Very rudimentary, very basic. Okay, now you've got 30 years of work going on here. It wasn't until actually 2018, do you believe it, when we were able to now move to there was one large language model. Dr. Bautista is very aware of this because he used it in his dissertation to work on these discriminatory practices in lending. Very, very interesting project. 2018 to now, we have all these large language models. So you have this whole history. Natural language processing went through and developed what we say behavior analytics, sentiment analysis, and now you're looking at all of these other things that you're talking about. So here in one summer, you're able to pull where we've come from, where we are today, and use these tools and large language models. My next question is, what's your next step with this? What do you plan to do with this?
So I know, as I said before, we're planning on writing a research paper right now, but we also want to get it up and running if possible, and then also get some feedback from those small scale farmers, and then add the language detection as well, just so it's functional and farmers could actually use it. And then after that, I would also say training it on more legal documents. We're limited to what was on the UPOV's data set, which was only 183 PDFs. But I think we can expand that as well in the future.
Oh, okay. Dr. Idell has a question.
Yeah, well, it's more or less a kind of comment. Very, very good paper. I enjoyed it tremendously. You might want to talk with Dr. Dentsu, who's the co-director of the Frank Kinder Center for Agroecology. They do a lot of work with farming and small farmers in kind of underdeveloped areas. And this may be something that he would be interested in. And if so, could possibly provide some funding or at least, the next step for kind of carrying this on.
Thank you.
If you're
And you
interested.
said Dr. Dentsu?
Dentsu, yeah, Kwesi Dentsu. And he's a professor here in the History Political Science Department. I think that he, you know, could possibly be interested in something like this as well.
Cool. Thank you.
Hello,
Mhm.
hello. I can't use the system to put my hands up. This is Dr. Coleman Onobise from the Brooksville Agricultural and Environmental Research Station.
Oh, thanks for coming on.
Yes, yes. This is how you're doing. Yeah,
Good to-
Alan, this is good job, excellent. Because this is an area, especially in breeding. I'm a plant breeder myself.
oh,
What might interest you is that the reason you have this switch from the two seed laws. In the early days, most of the plant breeders were in the public, that is USDA and universities. Then later on, the private companies became where the breeders are. And so those seed laws started changing. And so my question for you is this: how did you go from computer science, computer engineering to get interested in an area like this that many of us are struggling with?
mm. Mm. That's a good question. I would say for me, I always knew I wanted to work with technology and computers, but I didn't know exactly how. And then also growing up, I was always big on statistics and data, especially in like the sports field. I was an athlete growing up for a lot of my time. So I was like, how can I incorporate both those things? And then that's what brought me to data science. And then I realized just how many ways you can go about solving problems. And it's just very diverse. You could work with agriculture, you could work with credit card fraud, you could work with so many different things. So I just like the endless possibilities, really.
I would also suggest that Dr. Pata Bautista, are you still on board with us?
Oh yeah, I didn't there were some
Oh,
question.
no, no, I just want
about
I
that.
want to encourage Dr. Pata Bautista to introduce you to Mr. David Teak. David Teak is our director for he's an assistant vice president for technology transfer,
Mhm.
and definitely would like
Oh.
to have you meet with him. Dr. Potter, can you introduce can you introduce Alan to Mr. Teak?
Oh yeah, yeah, absolutely. Yeah, yeah. Actually, I will get in contact with Alan. He can come to also um present to my RAU students Sunday. So that I will talk with him. So get more in contact with him. So yeah.
Okay. So do we have other questions? Oh, there you are, Dale, our
Yeah, they are have some.
agriculture dean. Come on, Dale. Glad to see you, Dale.
Yeah, I did want to say that was my first question. I had two, but I was going to make that same suggestion that to get in touch with David Teak so that you can kind of claim some of this IP if that in fact is the case. But also, I just had a question. First of all, great presentation. I'm a little jealous. I think this is a great way of using AI for agricultural purposes. But one question I had though is how does it decide if it's got two conflicting questions? Like if the it does it know does the program know when a law or a regulation has been changed? So if you've got two conflicting, how does it make that decision?
I see what you're saying. The way we did that was more so manually. So when we had a document, like we had a couple of documents that were the same document over they were just revised like 3 or 4 times. What we would do is first we would do our due diligence, open all of them. But if the most recent one was just an extension of the old documents, we just remove them for now. But also in the future, we did want to come up with the feature so that it can know in 2015 the law was this, but now in 2025 the law is this. This is how it changed.
Thank you, Dale. It was really great. Yeah. Yeah. Go ahead, Dr. Onakapi.
Good afternoon. Okay,
Good
somebody
afternoon.
else. Yeah, go ahead. Yeah.
Oh, yeah, good afternoon. First, I wanted to make a point that Dr. Okinpace asked. One of the ways that we can help people trying to break into this field is the data science pairing with a different group. So, if you are in agriculture and you want to have some ideas that you think data science has some applications in, I think the best way you could get into it is not necessarily you becoming proficient or proficient data science. What happens is data science works with just about all the groupings, and so all we need is for us to work together, and then we can kind of put these things together. All right. The second thing that I want to point out right here is that it's important to notice how this thing can actually be applied, this concept can be applied to basically anywhere. If, for example, you're a historian and you have a whole bunch of PDF papers, you can pull all these papers into this network, and then you can ask that network questions about the papers that you're studying. If you're in the social sciences and you have a whole bunch of, say, reports on say, children in the foster system, you can pull all those papers together, and you can start asking them questions or laws about the foster system. Because, for example, that's something a lot of foster children might be wanting to know more about. And the point right there is that we're just scratching the surface of when and how we can use all of these tools. And so the real thing is just need to have a question that you can answer, a question that you're asking, and then hopefully we can help you fill in the details about how can you use artificial intelligence to help solve the problems that you have.
So, Alan, you just heard an underscoring of why you need to get with Mr. Teak. Absolutely fast.
Yeah.
Before other, there's all, I always tell all my collaborators in our research cluster that, you share ideas, but they get into the ether and other people pick them up. So you'd get with Mr. T, get Dr. Potter Bautista to introduce you to Mr. T ASAP.
Sounds
Because
good.
Dr. Maurice has indicated this has applications in many, many.
Exactly.
I mean, it's a fundamental application. It's a fundamental tool for many applications, And we have a historian on board here that heard that Dr. Idal. Anyway, yeah, any other questions?
Alan, I'm sorry. Alan, could you put that diagram you have of those companies so folks can see that these private companies have bought up all the seed companies? So that, yeah, you're right here.
Oh, wow.
Yes, you see, there used to be many small seed companies, but they were all bought over by Bayer. For example, Corteva, used to be Pioneer Hybrid Seeds based in Iowa. BASF and all of these companies. But the other thing that I like to suggest or bring to the fore is I like to see how this will deal with a small scale farmer and how they can readily get information because there have been so many lawsuits that these private companies are winning, except the one case in Mississippi. And I agree with everybody here. The earlier you take it to Dr. Teak over in what do you call it, technology transfer, many of us have had serious problems getting our stuff out. If you don't get it out early, somebody's gonna get it before you get there. So,
Yes.
but this is very, very Syngenta, for example, before we could get our fungus for invasive species control, somebody else had taken some notes at a conference we had, and it was gone.
Wow.
So the earlier you could do this, the better. So that I agree with Dr. Richard Allo that this is fundamental that you get it done ASAP. But thank you so much. And if you have questions on seed laws and seed science and seed technology, please do not hesitate to give me a call.
Okay.
Good.
Hey, thank you for your support. We appreciate it, Ken. And I underscore 100% what you said. The ether picks it up, and you need to get it out there and put your claims on it, Alan.
Mhm.
Very important. This is a very fascinating presentation. Congratulations to you. Any other questions? Any other questions? Alan, have you thought of
Um,
doing more work
um,
in data science?
I had a question.
Go ahead, Erda.
What cost did you guys entail in building and maintaining this system?
So at first, I would say roughly like $20 to $30 maybe, just because we're using an open AI key, especially to do the embedding models. We also used it when we came up with that squad data set, which is the question and answer pairs. That was also pretty pricey as well, but we knew we were working with a nonprofit, so we wanted to make everything open source. So everything from the embedding model to the LLM to the only thing we really paid for was the actual domain. I think it was $5 for maybe 3 years, something like that. But everything for our final model, it was completely free of use.
Yeah, the reason why I was asking that is that that's part of how you're helping the farmers, because that kind of information, that kind of website is not that difficult to keep up, and so it can be something that can be around for a long time.
Yeah, exactly. The cost, I mean, the cost benefit is big. The cost is low, the benefit's big, right? And tremendous, tremendous. Other questions? Okay. Well, if not, I want to thank you all for coming, and I want to thank Alan. Alan, I hope you continue on in data science because you've learned quite a bit. Oh, we have another question, Kyle. Dr. Ido.
No, I was just clapping. It was a very good presentation.
Oh, okay.
Thank you.
I join you in the clapping. Okay.
Get the physical one.
I'm sorry?
No, I said the physical, right? The physical clapping.
Yes. So thank you, Alan. But you continue on in data science, you can make big impacts on society.
Absolutely.
You see, look at your learning curve in the summer. Look at your learning curve. What you had no background in natural language processing. All right? There you are.
Not at all.
You're in the midst of something very, very big right now. Large language models are taking over a lot. Okay. So thank you so much. Thank you, everybody.
Thank you.
Take care.
Have a
Take care.
nice day.